Here's another factoring pattern which we haven't discussed before, which applies to binomials. It would take lots of experimenting to find it on your own. A sum of two cubes would look something like this: x to the third plus y to the third, or a difference of two cubes, which would be x to the third minus y to the third. So unlike with squares, we could only factor the difference of squares, and the sum of squares was prime. Here I can factor both a sum and a difference. So to start off, to find the first factor, if I have a cubed plus b cubed, I'm going to take the cube root, so whatever's raised to the third power is going to be the first term in this first parentheses. The sign is going to be the same, and then the cube root of the next one, which is b. So whatever's raised to the third power, and if I have a cubed minus b cubed, it's going to be a minus b. So the signs are going to match whatever was in the problem as we start out. Then once we find that first parentheses, we're going to use that first factor of a plus b to construct the second factor. So what we're going to do is square the first term. So if I'm starting with a plus b, my first term is a square, so I have to square it, I get a squared. The opposite sign, because this has a plus in it, is going to be a minus. The first term times the second is just going to be a times b. The next sign is always going to be a plus, doesn't matter what's happening before it. And then you're going to square the second term and get b squared. And so you see that written here. Here's the a plus b, and then here's my a squared minus ab plus b squared. So notice there's three terms in this. Note, it does not factor into a plus b times a plus b times a plus b. Does not do that. So that's an automatic wrong answer. And if I have a cubed minus b cubed, I'll start with the a minus b, and I'll square the first term. The opposite sign now is going to be a plus, so notice that the two are different at that point. I'm going to multiply a times b, and it's always plus b squared. So the second parentheses are going to, these two really just different signs. So the first one, a cubed plus b cubed, has a plus in the first parentheses, and it begins with a minus in the second. And the second one has a minus in it, and it begins with a plus in the larger parentheses. So let's then take this and work this problem. So 8 is really, what, 2 cubed? So x cubed plus 27 is 3 cubed, and then y cubed. So when I get my first parentheses, I'm going to take the cube root, which is 2x, same sign, which is plus, and then cube root of this, which is 3y. Then I'm going to take my first parentheses and square it. I mean, our first term and square it. So 2x times 2x is 4x squared. Whatever this sign is, I'm going to use the opposite, so there's going to be a minus. And then I'm going to multiply 2x times 3y. So 2 times 3 is 6, and then x, y. And then my last sign is always a plus. And then I'm going to take 3y and square it. So 3y times 3y, that's 9y squared. And so that would be my factored form of ax cubed plus 27y cubed. All right, so let's then work some. This will be y to the third, and 64 is 4 to the third. So when I write my first parentheses, it's going to be y plus 4. Then y times y is y squared, opposite signs minus. Multiply 4 times y, 4y, always plus, and then 4 times 4 is 16. 10, I have 2 cubes minus, and then you see that I have the m and the n, and they're going to be also cubed, both of them. So when I write my first parentheses, it's going to be 2 minus mn, so be sure you match that sign. Then 2 times 2 is 4, opposite signs plus, multiply them together and get 2mn, always plus, and then mn times mn is m squared, m squared. 27, number 11, this is going to be 3 cubed a cubed minus 1 cubed. So that's going to factor into 3a minus 1. So I can see these are cubes as opposed to squares, so notice that. Then 3a times 3a is 9a squared. Opposite signs plus. 1 times 3a is 3a. Always plus, and then 1. And the next one, I have 3 cubed, a cubed, b cubed. So that's a cube minus, and then that's 5 to the third power. So first parentheses is going to be 3ab minus 5. Then when I square that first one, I get 9a squared b squared. Opposite sign is plus. Multiply, and I'm going to get 15ab, always plus. 5 times 5 is 25. And this last example down here, x to the 6th is x squared raised to the third power. So x squared times x squared times x squared, and then minus 4 to the third. So when I factor this, this is going to give me x squared minus 4. And then I'm going to get, I'm going to square the first term, so that's going to be x squared times x squared, which is x to the 4th. Opposite side is plus 4x squared, and then plus 16. And I should make a note right here, a couple of things. The second parentheses, the one that has 3 terms, will never factor again. So you don't even have to think about that. However, the first parentheses, and I'm just going to point this out because its first parentheses here has x squared minus 4. And that is the difference of squares. So it actually will go one more step into x minus 2, x plus 2, and then the x to the 4th plus 4x squared plus 16 wouldn't factor if you were to try the AC method on that.